Hey everyone, welcome back. In today's explainer, we're going to explore the incredibly adaptable architecture of OpenClaw. If you've ever wondered how modern AI agents seamlessly connect to everything from WhatsApp to your local terminal commands, well, that's exactly what we're unpacking today. We're going straight to the core of the framework to look at its extensibility and the plugin system.
Here's our roadmap for today. First, the plugin-first philosophy. Next, we'll map out plugin discovery and loading, check out the registration API, dive into the event-driven hook system, and finally, look ahead to system resilience. Let's get right into it.
All right, part one, the plugin-first philosophy. To really get OpenClaw, you've got to understand its foundation. It is absolutely not some rigid, massive monolith. Instead, it lives and breathes this plugin-first mantra. Extensibility isn't just tacked on as an afterthought, it means that the core components themselves, stuff like the memory systems, messaging channels, the authentication providers, they're actually all just plugins under the hood. They literally use the exact same interfaces you'd use to build your own custom extension. And because of this setup, you can swap out pretty much any layer. Want your AI agent talking to a private internal database? Just build a tool plugin. Need it to hook into some super niche messaging protocol? Build a channel adapter. You can throw in services for background tasks, custom CLI commands, or even drop in entirely new AI providers if you want to run a local model instead. The whole system is basically just made up of these interchangeable Lego blocks. Moving right along to part two, plugin discovery and loading. So if everything is a plugin, how does OpenClaw actually find them when it boots up? Well, picture a flowchart here. It checks 4 specific sources in a strict step-by-step hierarchy. Step 1, it looks at the explicit config paths you've defined in your settings. Step 2, it scans your local workspace directory. Step 3, it checks your global user directory. And finally, Step 4, it looks for bundled extensions. Though, just a quick side note, those are actually disabled by default to keep the environment running lean. This multi-tiered approach, it gives you a massive amount of flexibility for deploying your custom code.
Now, once it locates those files, OpenClaw kicks off the loading phase. First up, it grabs the plugin's manifest file, just a simple JSON file declaring its identity and the permissions it needs. Next, it strictly validates that manifest against the JSON schema. Why? So bad configs fail immediately. No wasted time. Then we hit step 3, and this is a real game changer. It uses a tool called Jitty to dynamically load your TypeScript modules right at runtime. No messy build steps, no compiling, just boom, loaded. And finally, the plugin shakes hands with the system through the registration API.
Which brings us to part 3, the registration API. So the TypeScript is loaded into memory, right? But how does it actually wire into OpenClaw's brain? Think of the registration API like the system's central nervous system. It lets these totally separate code blocks plug straight into central command. Want your agent to browse the web? Your plugin just calls API register tool. Building a custom Slack integration? You use API register channel. Swapping out Anthropic for a local model? That's API register provider. It's this beautiful, clean, and strictly typed interface that makes extending the framework incredibly safe and totally predictable.
Next up, part 4, the event-driven hook system.
Now, those API methods we just talked about, they're fantastic for adding static capabilities. But what if you need to intercept data right on the fly? That's where the event-driven hook system comes in. If the registration API is the spinal cord, hooks are the individual nerve endings scattered throughout the OpenClaw lifecycle. Plugins can attach to these exact, precise moments to either react to a stimulus, like a new incoming message, or literally intercept and modify that data before it continues down the pipeline.
Let's make this concrete with 2 absolute powerhouse hooks. First up, message received. This one fires the exact millisecond a message hits the gateway. Since it's a modifying hook, your plugin could intercept an incoming message, translate it into another language, and then pass that newly translated version down the line. Pretty cool, right? Now, compare that with before agent start. This hook fires right before the system packages up the prompt to send to the AI model. A plugin hanging out here could inject extra memory context, or, and this is super clever, it could dynamically tweak the LLM's temperature setting right before it fires.
The biggest takeaway here is understanding the fundamental difference between the 2 types of hooks. You have modifying hooks, like message_sending or after tool call. These literally let your plugin change the data payload. If your plugin returns modified data, the whole rest of the system uses your new version. But then you have void hooks, like message sent or agent end. These are strictly observational.
You can't change the data with them, but they are absolutely perfect for kicking off a background process, saving a record to a database, or logging analytics after an event has already happened.
And finally, part 5. Up next, resilience.
All right, so we've seen how OpenClaw uses this plugin-first design, dynamic runtime loading, and event-driven hooks to become just insanely adaptable. But here's the catch. All of this power assumes the brain of the whole operation, the AI model itself, actually responds. Out in the real world, APIs time out, context windows get totally maxed out, and rate limits will hit you hard. So what actually happens when the underlying LLM fails mid-task? Does your custom tool just crash and burn? Well, that is exactly what we're going to unpack in our next explainer as we tackle OpenClaw's incredibly robust model fallback chains and system resilience. It's going to be a good one, so stay focused, and I'll see you next time.